Hello, my name is Scheuerman, and I am presenting this work on behalf of myself and my co-author, Jed Brubaker, titled Products of Positionality, How Tech Workers Shape Identity Concepts in Computer Vision. To talk about how identity is embedded in computer vision, let's first quickly define computer vision. Computer vision is a specific domain of machine learning focused on visual pattern recognition. Basically, a computer is taught to recognize concepts in visual data. For example, a lot of my own prior work has focused on how computer vision is used to classify gender and race in images of people. At this point, most major tech companies have dedicated cloud-based computer vision platforms for purchase. Google, Microsoft, IBM, and Amazon all sell computer vision to clients. Computer vision is a technology that is heavily reliant on making classifications about humans and human culture. As such, it has been heavily critiqued for its propensity for identity-related bias and harmful representations. For example, researchers have discovered troubling outcomes for people of color, trans people, and women, even when identity is not explicitly encoded into model outputs. As those of us in HCI know, computers are designed by people. Given computer vision is designed by people, identity approaches are not simply neutral. How identity is embedded in computer vision is the result of the decisions made by human actors. In this work, we explore how industry tech workers are responsible for the design of enterprise-level computer vision systems. More specifically, we investigate how worker positionality influences the design of identity concepts for computer vision technologies. At a high level, positionality describes how the position a person occupies shapes the way they view and interact with the world. Positional vantage points that influence how we see the world include identities like gender, race, nationality, sexuality, profession, and more. In this work, we attended 3 research questions. 1. How do positionalities of tech workers impact the development of identity in computer vision? 2. How do tech workers negotiate their own positionalities within their organizations? And 3, what happens when tech workers fail to account for other positional vantage points? To answer these research questions, we conduct semi-structured interviews with full-time employees at technology companies. We elicit descriptions of participants' roles and the products they worked on, how identity characteristics were embedded into those products, how decisions shape those characteristics, and the constraints and difficulties they faced in implementing those characteristics. We interviewed a total of 24 participants working at 12 different tech companies. These companies range from large household names to smaller startups. Participants worked in a variety of roles, including but not limited to software engineering, user experience, research, and data science. They also represented different employment ranks, ranging from interns to C-level, but all participants worked on computer vision. In our paper, we first show how identity is generally defined in the products that participants are working on. We then showcase findings on organizational contexts, because to understand the influence of worker positionality on identity concepts in computer vision, we had to understand the broader landscape workers are situated in. We then present findings on how individual worker positionality influences the way they approach identity work in computer vision. Finally, we show how positional gaps in tech worker teams can lead to unforeseen identity outcomes in computer vision products. In this presentation, I will briefly go over findings from each section. First, I want to lay the groundwork for how participants described defining identity within the context they are working in. After all, before building a computer vision product, workers define what identity should look like and how it should be scoped. We saw identity show up in computer vision products in 3 ways. 1, in explicit identity classifications. For example, in gender classification models where model outputs include explicit gender categories. 2, in implicit identity classifications. For example, datasets would be labeled with concepts like race so that workers could test their models for racial biases. And 3, in non-human objects which were still imbued with sociocultural meaning. For example, content moderation models being taught to recognize an image as not safe for work are still embedded with cultural beliefs about gender, sexuality, and purity. Identity in number 1 and 2 here were generally represented as rigid demographic categories or numeric approximations of identity concepts like skin tone. Identity in number 3 was much more intangible, often not explicitly measured or tagged in any way. For example, women in bikinis being tagged as explicit meant embedding gendered beliefs implicitly rather than explicitly. And it was not easy for workers to define identity. For example, Lynn explained how quote-unquote intimidating it was to determine how to measure racial categories for bias testing her company's computer vision model. She said, the kind of resounding sentiment from the team was like, we have to constrain this problem because it's an impossibility criterion if we just allow ourselves to think about every single phenotype and every single appearance of human facial features. So leaving those out was just based on skin color, I guess, right? So you have to think about where is maybe a standardized thing I can steal from, and well, there's the US Census, which is highly problematic. Here we see that Lynn and her team felt they needed to constrain identity to specific categories, because otherwise identifying racial bias in the model would be impossible. But they also did not know where to turn because many resources for defining race are historically problematic. In this last example, we can also see that approaches to identity do not come from nowhere. We found workers defining identity due to factors like product needs, the difficulty of obtaining data for certain identity groups, notions of common sense, and also the organizations they are embedded within. Organizational context in particular introduced factors such as economic constraints, which influenced how workers could approach identity given the resources they had to dedicate towards things like research or ethical data collection. Regulation and policy, which influenced the kind of categories certain products must include, and company values, which influence whether workers internalize the perceived values and approaches of their company and its products. Now that the contextual factors in which workers are situated have been established, I want to show how worker positionality influenced computer vision products. First of all, many participants were interested in working on identity issues for computer vision because of their own personal values and affinities with certain identities. Workers regularly made subjective judgments about how to approach defining identity based on their own identity experiences. For example, Vasuda knew from her own personal experience that if they were to use skin tone as a metric, a facial recognition system may perform poorly over periods of time as a person's skin tone fluctuated. She described how she was a brown person and having a lot more melanin content, her skin would change drastically under the sun and across age. So this was a poor metric for actually measuring bias. Of course, this did not make the decision for what categories to use instead easier or more concretely correct. Vasuda's personal identity made asking questions about the viability of skin tone more obvious to her, but she wasn't sure what the best course of action was. Participants also lamented values or perspectives that differed from their own. For example, take Coleman. He described choosing human characteristics that seemed quote-unquote useful. He said, part of me is a researcher who wants to get basically whatever data I can get my hands on, toss it into the data grinder, and build models. Coleman described how his identity as a machine learning researcher led to a desire to build new models and focus on improving methods, perhaps at the expense of fairness. Coleman's utilitarian approach was regularly critiqued by other participants. For example, take Elliot, who critiqued a more technical approach to scoping identity. In particular, Elliot was concerned with how categories like race and gender are represented, implicitly because of a personal stake in gender as a non-binary person. They said, it's predominantly white cis male engineers who have not thought too much about identity. Elliot explicitly questioned the positions many engineers inhabit, white, cis, and male, and assumed they lend to a less thoughtful approach to identity. Participants made their own positionalities clear through their disagreement with the perspectives of their colleagues. And just as decisions about identity are not made in a vacuum, they were also not made by individuals. Participants regularly had to contend with the positionalities of their colleagues, both those they agreed and disagreed with. For example, Madison described how the company and those in it were not supportive of addressing identity-based biases in products, and so it was this uphill battle with those in more powerful positions who did not value her perspective. She felt that, as a woman, her ideas were taken less seriously than those of men. She believed that such perspectives were so deeply ingrained in people's approaches that they weren't even necessarily aware they were being biased. She said, "I guess it's just this desire to maintain a white, Asian, cis male view of the world is so strong, and people don't even realize they're doing it." To ensure her perspectives were listened to, Madison described relying on white and Asian cis male allies to communicate her ideas about identity bias for her. So participants approached their work from their own positional perspectives. They also had to negotiate these perspectives with others who had different perspectives. Sometimes certain perspectives on identity won out, being embedded into computer vision products. Yet positional perspectives are inherently incomplete images of the world. Once products were finished being developed, identity issues sometimes still arose during testing or deployment. Participants described different instances where identity issues became apparent after development ended. For example, Madison described a development team of men who created a wearable not knowing it would be uncomfortable for people with breasts to wear. Lynn described a binary, sex-based gender classifier leading to trans and gender queer employees at the company protesting the product's launch. And Coleman described an image-based translation model that mistranslated and misgendered key Russian names and religious entities, which they only discovered via user complaints. These issues were largely caused by the development team being unable to foresee them, because they did not occupy identity positions that would make such issues obvious. In the end, tech workers all bring their own positionalities to the table. These perspectives are influenced and constrained by their organizations and their fellow workers. Rather than viewing positionality as a problem to be solved by aiming for an impossible notion of objectivity, we promote practitioners and researchers alike explicitly attend to positionality. The goal would be to understand, identify, and attend to gaps before they become unforeseen outcomes. We propose that researchers and practitioners attend to positionality from two perspectives. One, attending to contexts, and two, attending to actors within those contexts. Both perspectives are not mutually exclusive. They can be attended to in tandem or in relationship with one another. For example, a product team might consider the social factors of the culture they are embedded in and how they influence their preconceived notions about race. Similarly, researchers might unearth how supervisors enact their own positional models of identity rather than focus on bias mitigation for data workers. Overall, we still see boundless opportunities to consider positionality throughout the organizational ladder and the development process. Of course, we also want to explicitly acknowledge that actually attending to positionality is extremely complicated, as it is often a nuanced, implicit, and intersectional phenomenon that is neither static nor generalizable. First, unearthing positionality with relevant actors is extremely difficult, because many people do not realize how their own positionality influences their work. Second, positional perspectives carry specific values. Decisions must be made for which values will be implemented. Not all values should be weighted equally in all scenarios. And third, it is difficult to disentangle the role of intersectionality in shaping and constraining positionality. After all, not all workers have the same power to shape identity and product, and this is compounded when multiple positions are disempowered. As Davis writes, a dataset is worldview. This, of course, extends beyond datasets to encompass AI systems broadly. The worldview that a computer vision model holds is the result of the worldviews of the humans working to produce it. There is still so much work to be done on the role of positionality in technology development, and how we might shift practice away from universalism to embracing multiple worldviews. I want to thank you so much for listening, and also invite you to read the full paper at the URL on the slides, or reach out to me with any questions or comments at my email or on X. Thank you.